Hi class, this is Dr. Karsten, and today we are doing lesson 31, and this is from Module 5, Grade 4, EngageNY Math. And in today's lesson, we are going to be adding mixed numbers. So yesterday we added a mixed number and a fraction. Today we're going to be adding two mixed numbers. And we're going to do that by combining like units. So let's jump right in. And I'm going to plan on doing this a couple of different ways with you, 3 ways actually to be exact. So let's start off with two mixed numbers that we're going to work with. So let's start with 5 and 1/4 plus 1 and 2/4. So for this example, my units are going to be my ones and my fourths. My ones are my whole numbers, 5 and 1, and then my fourths are right here. I have 1/4 and 2/4. And the way that we did it yesterday was that we pulled our mixed numbers apart. So for example, instead of saying that I have 5 and 1/4, we said, well, this would be the same thing as having 5 plus 1/4. And then we could do the same thing with 1 and 2/4. So let's start off that same way. So I could say that I have 5 and 1/4 plus 1 and 2/4. And now what I can do is I can go ahead and combine my like units. So I can combine my whole numbers. 5 plus 1 is 6. And I can combine my fractions. 1/4 plus 2/4 is 3/4. So let's go ahead and write that. So 5 and 1 was 6. And 1/4 and 2/4 is 3/4. Now I just want to show you how we could do that, or why we can do that really quickly, because I really do want you to understand it. So the first thing that we could have done here, if we want to do this mathematically and show what we did, was we could have used the commutative property to switch these two places. Remember, when you're adding or you're multiplying, you are allowed to switch the order of your numbers. So I'm going to go ahead and do that. I'm just going to move them around. So we're going to have 5, and then instead of having 1/4, I'm going to swap out 1/4 and 1. So it'll be 5 plus 1 plus 1/4 plus 2/4. And then what we did was we associated them. So remember, the associative property is who you put together. So we're going to group these together, 5 plus 1, and we're going to group these two together, 1/4 and 2/4. And you're allowed to do that. Again, when you're adding or multiplying, you can move them around. So now 5 plus 1 is 6, plus 1/4 plus 2/4. So 1/4 plus 2/4 is 3/4. Remember, you keep the denominator. The denominators are the same. We just keep it. And then I can go ahead and just add that and put them back together. So I have 6 and 3/4. So that's the first way I want to show you this. Okay, so now if you're feeling pretty confident, you can continue to do it this way. But I'm going to just show you 2 more ways to do it. But before I do that, I am going to give you our first mystery clue word. And here it is. The first word is soccer. Okay, so soccer, S-O-C-C-E-R, soccer. So let's go ahead and let's move on, and let's try a different way of doing this. So another way that I could do this is, instead of doing it, well, let's do the number line way actually. I have a reason for doing it in this order. So let's do the number line way. So let's go ahead and draw a number line. Now, here's the thing. You can actually draw the number line and do the number line alone in so many different ways. So I'm actually going to do the number line, I think, in 2 different ways. So I know that I'm going to start with 5, because that's where I started off. I started with 5 and 1/4, and I added 1 and 2/4 to that. So I'm going to do it 2 ways. So I'm going to start here with 5, and then I know that I'm going past 6, but I'm not going past 7, so I'm going to put 6 and 7. And again, when you're drawing your number line, you have to look at what is in your denominator. So here, to know what you're partitioning, so since I have 4 in my denominator, I have to partition these into fourths. So I'm going to go ahead and do that. So you can see that I have 1/4, 2/4, 3/4, 4/4, and then again 1, 2, 3, 4. So I'm going to start with 5 and 1/4. Now I'm going to do this two different ways again. So the first way is I'm going to start with this number, 5 and a fourth. So here's 5 and 1/4, and I'm going to mark that. And then what I want to do is I want to add 1 and 2/4. And it's separated here for us, but you can see we have 1 and 2/4, and it's separated. So let me first add that 1 on. So this is one way to do it. So I'm going to add that 1. Let me pull it down a little. So first I'm going to add 1 whole. So if I add 1 whole, I'm going to go from 5 and a fourth to 6 and a fourth. And this is just one way to do it. And then I want to go ahead and add those other 2/4 on. So first I add 1 whole, and now I'm going to add 2/4, so 1, 2. So that's plus 2/4. And I end up at 6 and 1, 2, 3/4, which is exactly what we've been getting. Okay, so that's one possible way to do it. Let's do another way on the number line. So for this one, and I don't want to have to draw a huge number line, but another way that some people have thought about doing this, or that someone might think about doing this, I'm going to make the number line look the same, but you're going to see what makes it different in a second. So I'm going to start by, I wouldn't actually have done it this way based on what I'm using for this one, but let's go ahead and do this anyway. Okay, so another way to think about this, and I'm going to give us our problem right here really quick. So again, we had 5 and a fourth plus 1 and 2/4 was the original problem. So just so we know what we're working with. So one thing that we could do is we could say, well, couldn't we add our 5 and our 1 and just start at 6? And then what we could do is we could model 1/4. So I'm going to go 1/4. And then I'm going to add 2/4. 1, 2. And where we ended up was 6 and 1, 2, 3/4. So that's another way that we could have used a number line. So now we've done two different ways so far. The first way was the way we did it yesterday, where we used the commutative and associative properties. We broke things apart, and then we added our like units. So we added our 1s, and then we added our 4ths. And then another way that we could do it is to use a number line. We did two different versions of a number line, and there are other ways you could do it with the number line. It's just however you see it. Now the last way that I want to do this is a slightly different way from what we've done before. So let me first rewrite our equation here, our number sentence. So 5 and a fourth plus 1 and 2/4. So this is going to be a little different, but it's something that I think will be useful to you in the future. Instead of doing it horizontally, could we line these up vertically? Just like let's say that I was adding, I don't know, 23 plus, let's say 31. And then I could first add my 1s. So let's go ahead and add our 1. So 3 plus 1 is 4. And let's go ahead and let's add our 10s here. So 2 plus 3, or 2 10s plus 3 10s would be 5 10s, or 50, so 54. Just like we do that, we can go ahead and we can line these up. So I could do 5 and 1/4 and add 1 and 2/4. Now I'm kind of getting a little ahead of ourselves, but for some people this just really works. And so I want to give this to you as a way of working with this. So now what we can do is we can go ahead and we can add our 4ths. So we have 1/4 and 2/4, and that gives us 3/4. And we can add our 1s. 5 plus 1 is 6. So we're doing this exactly how you've learned to add in the past, and then we can actually do this when we get to larger numbers too, and when we're working with larger fractions. So let's try another problem, and we're going to do it. I'm not going to do the number line way, I think. I think I'm just going to stick with the the two other ways, but I did want to model that number line way for you just so you're comfortable with it. So let's try another problem. So let's do 2 and 3/5 plus 3 4/5. So in this case, my units are going to be my ones, are going to be my ones again. And this time I'm going to have fifths. So let's do it the horizontal way first. So what I want to do is I first want to pull apart my 2 3/5, so show that it's 2 3/5. And then I'm going to show my 3 4/5. And then, you know, some of you might want to just shortcut it, and just kind of draw a V here to say, well, these are equal to 5, and then V these together and see how many fifths you have. But I'm going to go ahead and flip them just so that we really see what we're doing. So I'm going to use the commutative property to switch the order. So we're going to end up with 2 plus 3, so I'm grouping these two together, plus, now I have to write that one, 3/5 plus 4/5. And again, I just switched the order here. Now let's model the associative property. We're going to see who we're going to add together. So we're going to add our ones together, and we're going to add our fifths together. Oops. So now I'm going to go ahead and I'm going to take this, and I'm going to get 2 plus 3 is 5, and 3/5 plus 4/5 is 7/5. Now I'm hoping that all of you are suddenly realizing that we have a fraction greater than 1. And whenever we have a fraction greater than 1, we want to go ahead and we want to pull that apart, right? We want to convert it into a mixed number, because we want to make sure that we have all of our units together, all of our ones together, our whole numbers together. So let's go ahead and figure out how we're going to do that. Now, the other thing that we always talk about in our classroom is that we want to have a rule, and our rule is based on our denominator when we're working with these numbers. So since our denominator is 5, our rule for this whole problem always will be that 5/5 is equal to 1. So that's going to be our rule, and what we want to do is we want to pull out groups of 5/5 out of 7/5. So let's go ahead and see what we can pull out of there. So I can pull 5/5 out, right? So we had 7 pieces. I'm putting 5 there. How many do I have left? I have 2 pieces, and the size is fifths. So 7/5, put 5/5 here and 2/5 here. 5/5 plus 2/5 is 7/5. And we can even still keep that addition symbol in between like we've been doing. And we still have our 5. And now what we can do is we can turn that 5/5 into one whole. So we have 1, and we still have our 5, and we have our 2/5. So 5 is still 5, 5/5, here's our rule, becomes 1, and the 2/5 stays 2/5. And now we can go ahead and we can group together, we can associate the 5 and the 1 to make 6. And we have 6 plus 2/5, which is just 6 2/5. So there's our answer. Oops, there we go. So we have 6 2/5, which is just 6 2/5. So there's our answer, and we could go ahead and write that up top, equals 6 2/5. So now let's go ahead and let's try that vertically. So let's do the same problem, but let's add them vertically. So there's our original problem. Oh, and let me give you the second word from our clue, and the second word is going to be ball, B-A-L-L, ball. Okay, so here we go. So we have 2 3/5. See, I'm just kind of lining them up here, plus 3 4/5. Okay. So now what I'm going to do is first I'm going to add my fifths. So I have 3/5 plus 4/5. 3 plus 4 is 7, and they're all fifths. And 2 plus 3, oh, I should be writing an addition symbol. 2 plus 3 is 5. And now I have the same thing where I have to say, well, 7/5 is going to give me, is a fraction greater than 1. So I need to go ahead and I need to show that. So again, we pull out a group of 5/5 and be left with 2/5. And we still have our 5. And we're just doing the exact same thing we did before. So this becomes 1 plus 2/5 plus 5. And 5 plus 1 is 6 plus 2/5. So again, we got the same exact answer. So no matter which way you're doing this, you are definitely going to get the same answer. You can pick the way that you are the most comfortable with. You can do it horizontally, you can do it vertically, or you can go ahead and you can use a number line. So let's take a look at a couple of the problems from the problem set in lesson 31. And I had them here. Here we go. So we're going to be jumping around kind of like we did yesterday. We're not necessarily going to do all of the problems. So let's see what we have here. So the first one they already did for us. So let's go ahead and take a look at 1b. So here it says 4 1/4 plus 3 2/4. So again, you can do it however you want. I am going to go ahead and first do it by doing it horizontally, and I'm going to pull these apart. So again, I need a little bit more room, so I'm going to work right here. So I have 4 plus 1/4 plus 3 plus 2/4. And now I'm going to just move these around. I want to show that I'm adding the 4 and 3, which is 7, and the 1/4 and the 2/4, which is 3/4. And if you see that, you can just write the answer. You don't have to do all this other work that I'm doing. But I'm going to go ahead and flip these around. So I'm going to have 4 plus 3, I'm just putting those two together, plus 1/4 plus 2/4. And 4 plus 3 is 7, plus 1/4 plus 2/4 is 3/4, which is just going to be equal to 7 and 3/4. Similarly, like we just said, you could have done them vertically. So we could have said 4 1/4 plus 3 2/4. 1/4 plus 2/4 is 3/4, and 4 plus 3 is 7. And you get the exact same answer. So whichever way you're comfortable with, you could have done a number line, whatever works for you. So let's go ahead and let's do this one next together, because I think I'm going to have you focus on the last page. So here we're going to have 2 2/6 plus 6 6/4. And actually, let me go ahead. I'm going to start pulling them apart already. So we're going to have 2 plus 2/6 plus 6 plus 4/6. And now I can just go ahead and use the commutative property to switch those around. So 2 plus 6, I'm putting my whole numbers or my units together. And now I'm going to put my 6 together. So I have 2/6 plus 4/6. And I have to keep going over here to the right. So I'm going to end up with 8 plus 6/6. And I hope that everyone is noticing 6/6 is just equal to 1. So this is really just 8 plus 1, which is 9. Okay, so I am looking here at question number 2, and actually when I look ahead, we really don't have that many questions in this problem set when we get to the second page. So here's what I'd like to do. I'm going to take just a quick peek with you. I think we've actually probably done enough problems, but let's just take a quick peek here. I want to show you something. It says solve using a number line to show your work. Again, I don't need you to do a number line. I am okay with you doing this whichever way you are comfortable, because we did just take a really nice break from this and focus on you being comfortable with fractions and working with them. And we made sure that everyone's really a superstar at fractions. So we do not need to use a number line. So if you want to do these problems, you can. But really what I want you to do is I want you to focus on this last page. And this is where you're going to do the work. So they started this one out for us, where they went ahead and did some adding. But again, I'm not fond of doing it this way. I'd rather model it a different way. So I'm going to help you doing this, and we're not going to do the arrow way. I don't want you guys to get confused by that. I think that while we're doing the type of learning we are, this is not going to be useful to us. So instead, what I'd like you to do is focus on just adding this, solving whichever way you're comfortable with. So I'm going to focus on this and pull these apart. So here's the original number sentence. 2 4/6 plus 1 5/6. So I'm going to go ahead and do 2 plus 4/6 plus 1 plus 5/6. And again, if you're comfortable right now, you can just say 2 plus 1 is 3, and 4/6 plus 5/6 is 9/6. And you could go ahead and write that. But for those who really need us to flip it around, I'm going to show that I have 2 plus 1. Now I'm just commuting these, going back and forth, plus 4/6 plus 5/6. And now what I want to do is I want to group these. So I have 2 plus 1 and 4/6 plus 5/6. And what I end up with here is 2 plus 1 is 3, plus 4/6 and 5/6 is 9/6. I'm starting to kind of encroach on this next problem, but I'm not modeling that one, so that's okay. So now I again have a fraction greater than 1. So we have to think about what is the rule for this problem. And if I look at this problem, I have 6th in my denominator. So my rule is going to be that 6/6 is equal to 1. So remember, you look to the denominator for the rule for the problem. So now I can pull out my groups of 6/6 out of this fraction greater than 1, and so I can convert it to a mixed number. So I'm going to pull out 6/6, and if I have 9/6, then I put 6 here. That leaves me 3 of them over here. Remember, 9 minus 6 is 3, or 6 plus 3 is 9. We keep the same denominator. And I still have my 3. So I have 3 plus this plus this. And now remember, 6/6 is just equal to 1. So really what I have is 3 plus 1 plus 3/6, or if I combine these, I get 4 plus 3/6, which is just equal to 4 and 3/6. Again, the other way that we could have done this was to stack them and add them. So we started with 2 and 4/6, and we're adding 1 and 5/6. Then I wrote that a little big, sorry. So 4/6 and 5/6 is 9/6, and 2 plus 1 is 3. But then again, I have to take this fraction greater than 1 and convert it to a mixed number. So again, I'm going to pull out groups of 6/6. I'm left with 3/6, because 6 and 3 is 9, and I'm going to keep that 3. So now again, this becomes a 1, so I have 3 plus 1 plus 3/6, which is again going to be equal to 4 and 3/6. Okay, so you have different ways of doing this. You can do it whichever way you want. I'm going to give you that third code now. And the third code is SCORE. S-C-O-R-E. SCORE. Okay, so your work is to do from the problem set in lesson 31. You are going to be doing B from number 3, B, C, and from number 4, A, B, C. And you may solve them whichever method you prefer. So again, you can see I crossed this out. You may solve these in whichever method you prefer. All right, so that's it. So you have your 3 code words. Make sure you put those into your work tomorrow, and I'll see you in our Google Classroom. Have a great day, everybody.